Hi, you guys. This is Miss Pruitt, and I don't know how you guys talk me into this, but I'm going to make a video for you guys. We are having a test tomorrow, so please make sure you check the website for um, for the solutions to all of our review problems. So let's go ahead and get started. If you would notice that these questions are coming from the second review sheet. So, first question, a student wants to save $8,000 for college in 5 years. How much should be put into an account that earns 5.2% annual interest compounded continuously? So, as always, our very first step is to figure out which equation we're going to use. And I see here my magic word continuously. So, between my options, I am going to use the A equals PERT, right? A of T, my ending amount, is going to be my principal times E to the RT. So my ending amount that I want is 8,000. I don't know what my initial value is, but I do know E. It's in my calculator. R is my rate converted to a decimal, so it's 0.052, and T is time, and in this question, it's 5 years. So, I want to get P by itself. Well, as a sidebar, think of it like this. What if I had 25 equals P times 5, and I want to get P by itself? Of course, what you would do then is divide both sides by everything else, right? Except for the P. That's exactly what we're going to do for the problem that we're presently working on. I'm going to divide everything, both sides, by this number. Because if I plug this into my calculator, it's just a number. It is just a number. So that's supposed to be a multiplication sign. And go ahead and plug that in because all of this stuff will end up canceling out. You plug that into your calculator and you should get $6,168.42. Okay, next. Carbon-14 is used to determine the age of artifacts in carbon dating. It has a half-life of 5,730 years. Write the exponential decay function for a 24 milligram sample. Find the amount of carbon-14 remaining after 30 millennia. And I'm showing you that 1 millennium is 1,000 years. All right, so first off, looking at this, I need to figure out what equation I'm using. Well, I see my keyword here. I hate when that happens. My keyword is half-life. So I'm going to be using the half-life function. The half-life function is A of T equals A naught, my initial amount, times 1/2 to the T divided by K, where T is the amount of time that has passed and K is your half-life years. So for this particular equation, I want to know after 30,000 years, because it's saying 30 millennia. And if we're talking about 30 millennia, 1 millennium is 1,000 years, where 30 of those 1,000 years should be 30,000 years. So that function, or A of 30,000, is equal to my initial amount, which is 24 milligrams, times 1/2 to the amount of time that has passed, my T value, which is 30,000, looks weird without my little slashes, divided by the half-life, which is 5,730 years. So, you can plug that into your calculator, and you should get 637 milligrams. All right, you guys, for the next problem, the world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.26%. Write a function to model world population growth since 2000. Then predict the population in the year 2040. So my key word here is population. Whenever I see population, I know it's going to have continuous growth. Our growth is, our population is not going to grow in a compound way. But it is similar to the A equals PERT, right? So first up, you need to figure out which equation you're using. We are using A of t equals A naught e to the kt, where A naught is my original or my initial value, E is in my calculator, K is my rate, T is the time in years. So I want to know, first things first, it wants us to write a function for this in particular. So A of, if we're looking for, well, first let's do A of t. It will be my initial amount, which is 6.08. It's understood that this is in billions, so I don't have to like write it all out. 6.08 billion times E to the K, which is my rate in decimals, so it's 0.0126. You move your decimal over 2 times to the left, times T. So that's my function. Now we're going to use this function to get the answer. My ending amount, well, we want to know what's going to be the population in 2040. If t equals 0 is at year 2000, then t equals 40 must be year 2040. So I want to know what happens 40 years later. So we will have 6.08 e to the 0.0126 times 40. And if you plug that into your calculator, you should get the population will be 10.06 billion. All right, next problem. You have inherited a house that was purchased for $20,000 in 1950. It is now 1995, and the value of the house increased by approximately 5% each year. What is the value of the house now? So once again, first things first, you need to figure out which equation you're going to use. Well, something is increasing, it is appreciating. We're going to use exponential growth. And that base function is just A of t, or excuse me, formula, A of t equals A naught, the original value, times b raised to the t power. Now that b needs to be broken down. What that b means, let me just draw a little arrow here, is 100% of your original value plus or minus whatever your rate is raised to the t power. So we're always going to use plus if something's appreciating, increasing, inclining in some kind of way. And we're going to use minus if there's any kind of depreciation, decline, anything like that. So for this instance, for this house, we are going to use plus because the house increased in value. So specific for this equation or for this problem, I would have A of, we need to figure out what t is. If we started in 1950 and we're right now in 1995, there's been 45 years that have passed. So initially the house was purchased for $20,000. I'm going to multiply that by 1 plus the rate. in decimals, which is 0.05, raised to the t, and that's 45. So if you plug that into your calculator, you should have gotten that the value of the house now is $179,700 and no, I don't want that. And 16 cents. And that's the answer. All right, you guys, last but not least, $20,000 is deposited in an account that pays 8% annual interest compounded monthly. What is the balance in 5 years? So first things first, you need to determine which equation you're going to use. My hints here are that I see that it's compounded monthly. I hate when I do that, you guys. I page over to the previous page. I apologize. Compounded monthly. That monthly is telling me how many times a year. So I know I'm going to use good old plain compound interest. That equation is A of t equals P times 1 plus your rate in decimals divided by the number of times it's compounding per year raised to the number of times it's compounded per year times t. So in this case, I'm going to fill in what I know. I know my principal amount. That's my initial amount, which is $2,000. So $2,000. 1 plus my annual interest rate. It's a pretty good bank. And that's at 8%. Divided by how many times it's compounding in a year. Well, if it's happening monthly, how many times is something monthly happening in a year? That's going to be 12. Raised to, once again, the same thing, the number of times it's compounding in a year, times how many years we're interested in. Well, the problem asks for 5 years. So I'm going to multiply it by 5. And that makes sense, right? That's going to give me how many times interest is going to be compounded in those 5 years. And it'll be 60. So if you plug all of this into your calculator, you would get that the balance in this account would be $2,979.69. And that's it, you guys.